Good afternoon, everyone. Or good morning, depending where you are. We've got a couple minutes before we officially start, but I'm just going to take this opportunity to go through some kind of quick housekeeping notes. First of all, we're going to be doing a Q&A at the end of the webinar. Please feel free to submit questions throughout, and you can do so in the questions drop-down in the GoToWebinar control panel. Likewise, if you're experiencing any technical difficulties, you can kind of put those questions in there as well. We're going to try to get to as many questions as possible. If we don't get to everyone, we'll just answer via email afterwards. Quick disclaimer, all information discussed in this webinar is for educational purposes only. It should not be applied directly to the administration of any particular file or claim. This webinar is being recorded and we will share it with you. We'll also be sending everybody a completion certificate. I know continuing education and accreditation is a hot topic right now. We're waiting to hear back from Saskatchewan and Alberta. Alberta, I know, met last week, I believe, so we should hear soon. It's never been an issue getting these things accredited, so please just bear with us and we'll get those completion certificates to you as quickly as possible. Actually, on that note, if you are looking for hours at the beginning of the year, we're going to be doing another webinar at the end of the month. It's a structural engineering webinar titled The Benefits of Digging Deeper. And we're also going to be doing, I'll just say this, an unofficial announcement. We're going to be doing our national tour in May as well. So if you're looking for hours, you should be able to get quite a few there. So Kevin, if I could just bother you to advance slides, we'll get underway. So today's presentation is investigating fuel burning appliances. We're going to be looking at industrial, commercial, and residential applications. Our presenters today are Kevin Abbott and John McCutcheon. Next slide, please. So Kevin Abbott is a fire and explosion investigator and fuel specialist. He's a licensed electrician, gas technician, and petroleum mechanic. He's completed hundreds of forensic investigations, including large losses, major fuel incidents involving equipment failure, injuries, and fatalities in improper installations. And his technical specialties include fire investigation, product liability, and fuels codes and standards. Next slide, please. And then our second presenter is John McCutcheon. John is also a fire and explosion investigator and fuel specialist. He's a construction and maintenance electrician, refrigeration and air conditioning systems mechanic, TSSA license G1, OBT1, LP petroleum PM23, and compressed natural gas and hydrogen mechanic. He's also wet certified, so that's for your solid fuel appliances, and a commissioned National Board pressure vessel inspector. He has over 20 years of experience and has completed nearly 100 forensic investigations. His technical specialties include fire investigation, product liability, fuels codes and standards, heat load, duct design, ventilation design, and legal review. And now I'm going to hand things off to Kevin. Kevin, please take it away.
Okay, I'd like to thank everybody for attending today. John and I were asked to put on this presentation, and we were very happy to do so. John and I have a similar pathway through life. After high school, we both enlisted in our respective militaries. We both served overseas. Upon return from overseas, we both pursued a career into the skilled trades. From the skilled trades, we ended up working for the regulatory authorities. We both enjoyed the fire investigation and the investigation side of that, and we both ultimately ended up at Origin Cause. So I'd just like to preface this that the purpose of the presentation is obviously to speak to fuel-fired equipment and some instances where there was, whether it be a fire explosion or an incident. I just want to preface it by saying that, fuels are a very safe and reliable source of energy, provided they are utilized properly. So the purpose of this is not to make anyone, rip the furnace out of their house for whatever reason. Fuels are extremely safe It's just typically when something goes wrong, they need to be investigated, and we'll take it from there. So the fuels that we know, the big three are at the top: natural gas, liquefied propane, commonly referred to as LP. Number two, fuel oil, which is diesel, heating oil, or your furnace oils. There's also solid fuels, which would be your wood stoves and your pellet stoves. Petroleum products, whether it be in the private setting with spills or in the public setting in gas stations. Fuel also provides energy for backup power and life safety requirements. Diesel, gaseous fuel generators. Compressed natural gas is starting to become more mainstream. We see this in vehicles as well as with ice resurfacing equipment. And a new area of technology that's coming in is hydrogen as a fuel, used primarily in vehicles and in material handling and equipment refueling. Fuels investigations and OCI. What I want everyone to think about is that any appliance is essentially a black box. And then that black box is supplied a fuel source, whether it's natural gas, whether it's propane, whether it's fuel oil. And that box will have an associated governing code book, an associated regulation, and an associated qualification in order to work on that. So at OCI, we have the knowledge, the expertise, the certification, and the experience to investigate and provide expert opinion on any appliance that burns either a gaseous, a liquid, or a solid fuel. And then the appliances, depending on how much fuel or how much energy they use, there can be potentially greater consequences, and there's more things that can go wrong. So the larger that a system is, it's often more complex, and it requires a deeper understanding of how the systems are designed, installed, integrated, and how they fail. So when we're investigating fuels throughout all of Canada, each province has what's called a regulatory having jurisdiction that governs their fuel safety program in their respective province. The Technical Standards and Safety Authority, who John and I both worked for, is responsible for that fuel safety in Ontario. However, throughout the country, there is a requirement to notify the authority having jurisdiction should the incident fall within the reporting requirements of whichever province you're in. Oftentimes, in the process of performing that investigation, a fire investigator may be excavating a home because there's been a fire, an explosion, and in the process of that investigation, they have a belief that potentially that explosion or that event was caused by a fuel source. There's the requirement to cease that investigation and then to notify the authority having jurisdiction in whatever province that you're in. So we're going to focus primarily on the top three. So we're going to start with know your natural gas. So natural gas is lighter than air. It has a specific gravity of 0.6. They add an odorant, ethyl mercaptan, to the fuel to make it sound like, just to make it smell like rotten eggs. It has an explosive range between 4% and 15%. And then the majority of the regulators and the meters are the property of whichever utility gas company is connected to your home. And then anything downstream of that meter, all the piping downstream of the meter, would be the responsibility of the owner. So here's just a few pictures of a typical natural gas meter and regulator that would be connected to the side of your house or your building. The picture farthest to the left is the typical meter set. The center picture is just more of a close-up of it, and then the picture to the right would be the regulator. Know your propane. So propane is heavier than air. It has a specific gravity of 1.56. There is also an odorant that is added to the fuel, which smells just like rotten eggs. Its explosive range is a little bit different. It's 2.15 to 9.6. And most of the cylinders and tanks that would be located on the property are owned and maintained by the fuel distributor. They're typically leased to the customer. And similar to in the natural gas applications, the piping downstream of the cylinder would be owned by the customer. This is typically The fuel is typically provided by two separate regulators, whereas there are some instances where there's a single stage regulator. And most often that is common when there's the double 420-pound cylinders located near the structure. And then the cylinders themselves, there's a requirement in the code that they need to be inspected and recertified every 10 years, similar to the cylinders that you would use on your propane tank for your barbecue. This is just a couple of photographs of how the typical arrangements that you would see on a home. So you see the two 420-pound cylinders to the left, whereas you would see that the larger 500-gallon tank installed on the right. This is just a diagram which depicts this. You know, we have the container, the 400 or the 500-gallon propane tank. There's typically an underground line that travels along and is connected to the house, oftentimes with the first stage regulator being at the tank and the second stage regulator located on the home. Or you have the two 420-pound tanks with the first stage regulator and potentially a dual purpose regulator, which is the integral to that, or a second stage regulator on the home. Here's some photographs of what they look like. The photograph to the left is the first stage regulator located at the tank, whereas the photograph to the right, you would see that second stage regulator. You see that underground supply line coming from the ground up, and then the vent for the regulator going to the left, and then the actual pipe that enters into the home, leaving vertically before traveling to the right. This is an integral first and second stage regulator that you see, and this is the most common system that you would find when you were utilizing a 420-pound cylinder for the purposes of providing fuel to your home. And with that, I will hand things over to John.
Thank you, Kevin. Yeah, I just want to thank everyone for taking the time out of their busy day to sit and listen to Kevin and I talk. Something that is so much a part of our lives, Kevin, Mike, Mark, Guy, and myself, is this fuels window. Like we will investigate any type of fire, cooking, smoking, incendiary. Like if you can burn it, we can dig it. But this is where we really focus and, in my opinion, thrive with fire investigation. So again, thank you all for listening in. With regard to fuel oil, there's a lot of people with the belief that there's a regulatory requirement to replace a tank, and it's not the case. There may be some insurance requirements that say, hey, after 10 years or after this period of time, you need to either switch to an alternative fuel or replace your tank. But from a legal or regulatory perspective, at least that I'm aware of, there is no requirement. Now, that's not to say that the homeowner or the owner of the equipment isn't required to have the equipment, the tank, the piping, the appliance inspected annually. And this is required not only through the B139, but as well as through most manufacturer certified installation instructions. So there's a legal requirement through the code, and then the code will also speak to the legal requirement to follow the manufacturer's instructions. And typically, in order for that appliance to be certified, the instructions also have to be certified with the appliance, and these requirements would apply. So, and then with regard to that, the technician that is being contracted to perform these annual inspections, they have a requirement to ensure that the equipment is operating in a safe condition and that any unacceptable conditions are addressed. And in Ontario, at least, this is through the 213 fuel oil regulation, but through any number of regulations present in each province. Fuel oil storage, your standard two types of residential fuel storage tanks. They also could be put into service in small commercial or even larger installations. The tank on your left is the old standby. It has the 4 legs. It is nowadays double walled. There was certainly a long period of time where this was nothing more than a single wall tank. And when that tank failed, there was an issue. And now regulations and requirements have come in to say, at the very least, you have a double-ended and double-bottomed tank, but most tanks now are double-walled. This is a nice image from Granby, which shows a cutaway. It shows the gauging mechanism, the float tube that's down the middle of the tank. There's a different number of bungs or openings at the top of the tank, depending on what needs to be tied into that tank. We'll see some images coming up of a different style of tank where there's multiple items and components monitoring and pulling from that tank. The tank on your right, this is kind of like the Cadillac of tanks, so to speak. This is the Kleenex name for this would be a Roth tank, although Granby and some other manufacturers probably manufacture a similar design. It's a polyethylene inner liner, and the outer coating is a galvanized steel. One of the benefits of this is they can be easily twinned or manifolded together in a much more pleasing manner than manifolding and hooking together the Granby steel tanks. The bottom support mechanism is similar to like a pallet. It provides a very firm, level base, whereas a big concern with the steel tank on the left is of course supporting it, right? You take approximately 265 gallons of fuel oil at about 7 pounds per gallon. You add the weight of the tank, you're around 2,000 pounds resting on 4 pretty small areas. So the proper support of this type of tank is very important. And this also speaks to the importance of annual inspections. If the tank is installed outside, certainly that tank on the left would need to be approved for an outdoor application, but provided it is, the firm and level supportive base that met the requirement when it was installed may have changed through the course of heaving or physical damage or anything else, right? So it's important that is inspected on an annual basis. But the tank on the right, these are beautiful tanks. If one would describe an oil tank as beautiful, I guess I would. But this one was the sad victim of, it was a great installation. The piping was good, the appliance was good, everything was done correctly, except the installing contractor failed to understand the location of the residence in which it was installed, and it happened to be in a floodplain. So the tank was installed, and shortly after there was a flood, and the tank was due to the polyethylene and the light construction of that tank. One of the benefits is the light weight of it. It floated and expelled a significant amount of fuel oil into the basement and ultimately into everywhere that was flooding. So it was rather costly. So always it comes down to the proper installation and the importance of hiring the appropriate contractors to do the work. So some fuel oil burner concerns, and I speak to this as fuel oil burners, but it's also the entire system, the storage, the piping, and also ultimately the appliance, the burner. So improper service, a good example of this would be having a burner service done, that annual service that's required for this equipment, and the technician fails to install the proper nozzle, or they fail to perform the proper tests and set the appliance up correctly, and you shortly thereafter end up with a tremendous amount of soot and damage to the appliance and possibly the residence. A lack of service or neglect. Certainly the picture on this slide speaks to neglect, and this is a supply and return piping system on a stationary engine, a generator in a commercial building. And you can certainly see that as the steel pipe is in contact with the masonry, and moisture and humidity and condensation over time have worn that pipe right down to the point that it's almost porous. In fact, there were portions elsewhere in this installation that were leaking a considerable amount of fuel oil to the inside of the garage. So neglect and service, and that speaks to the requirement of having it annually inspected. The improper installations, certainly improper installations are going to be a topic that we discuss through all types of appliances, but there's the misnomer or the thought that improper installations will present themselves immediately, and that's not always the case. There's a lot of equipment that's been installed and in operation for a considerable period of time, and it takes time for that equipment to fail. And the importance of having a competent, really experienced investigator in the fuels world to look at this stuff we'll be able to maybe determine if it was an installation and how it can be related to that. Physical damage, this is good. There's certainly a lot of those oil tanks we looked at installed outside, and most tanks nowadays come off the top, but there's a lot of them that still came off the bottom connections, and there might be a filter on there. And it certainly, in my life, I've seen a number of them where that filter is hit by a lawnmower or some other impact, or just damage to the tank that results in a release of fuel oil to the environment, and it becomes quite costly. And then, you know, the legendary tales of fuel tanks and basements having been removed, and the fuel oil distributor comes to do their annual or their fall fill up, and there's ultimately no tank in the basement. And so obviously there's requirements within the applicable codes and regulations across the country to take certain steps in the change of one form of energy to another. This is the tank I mentioned earlier with the number of bungs on the top. So this is an installation in an apartment building. Many times the stationary engines are fueled from the basement level, from the parking garage, and there's requirements within the fire code and within the fuel oil code, depending on the quantity of fuel stored as far as where that tank can be located. So many times the tank is in some part of the parking garage in the basement, and it is piped up to the penthouse potentially where the stationary engine is located. So there'll be a fill and a supply, there'll be some monitoring, there'll be a gauging, and then the larger pipes are your operating vent and emergency vent. So this particular installation with a remote tank, with a remote fill such as this, there's a pipe outside for the delivery driver to fill from. And there's commonly a box we call it the driver's box or the fill box. And there's a test switch. And so the driver on this particular day, he pulled up and he pressed the test switch in anticipation of an audible sound coming from the box that would be similar to when this tank reached its fill capacity. It would sound that same alarm. The driver pushed the button, failed to hear anything, but he said, well, I will just continue to fill it anyway. Perhaps there's a vent whistle, maybe I'll hear that. It wasn't until he got to around 5,000 liters on his meter on his pump that he realized this was an 1,100 liter tank, and there was probably an issue. So he found access to the building, went into the basement, and found several feet of diesel in the basement. The ultimate failure of this was the fact that since this tank was installed, and it was quite a number of years ago, what I would call the local fill, or this fill cap that's in the picture on the left, it was never removed. It was in that fill box. It's called a spill containment box. As you can see, it will hold some oil in there. It was left in place rather than being plugged as it should have been on the right. So this was a number of failures or faults in this particular loss. Certainly the delivery driver, as well as the initial installer, because this tank should have been correctly plugged in all of the ports that weren't in use. This type of installation also requires a comprehensive inspection by an OBT1. So there was some responsibility on that person who signed off on that comprehensive inspection. The B139.2 is part of a series of codes which addresses installation of oil burning equipment, and the .2 is specific to residential and small commercial buildings. The other parts of the code include large installations and stationary engines. So clause 11 of the .2 speaks to a number of specific detailed tests and observations that must be performed after installation, alteration, or servicing of combustion-related components. So that pretty well captures everything that a technician would do, right? He could install it, he could alter it in some way, adjust for combustion, or service it in that annual requirement for service. Even if it's something as simple as changing the nozzle and changing a filter, which is pretty typical stuff. Even if you don't want to have your oil-fired furnace or boiler serviced annually, your boiler or furnace is going to say, hey, I need a new nozzle at the very least. The diesel that is being marketed now, it's we're working to save the world with biodiesel and different alternative fuels. this is not how this equipment was originally designed to operate. So it does present some operational issues. And one of those is, at least in my experience, is nozzles being changed more frequently. So this clause though captures everything. So anytime that appliance is touched, that technician needs to perform each of these detailed tests and observations, and not only perform them, document it, right? If it's not documented, it didn't really happen. So if he can't produce a very detailed service report that says, hey, I did A, B, C, and D, and oftentimes there's the conversation too, right? How did you perform that? If they're not really sure how they're testing their smoke or they're pulling combustion or whatever they're doing, there's certainly an issue. Clause 12 speaks to the maintenance. So the oil burning equipment shall be inspected and maintained in accordance with the manufacturer's recommendations and at least to the minimum requirements in accordance of Annex L of the B139.1.0. So again, a different part of the same 139 series code. This speaks to the large commercial, but through this clause within the point 2, it ties in to residential equipment as well. So that clause speaks to an annex, Annex L, and some of the annexes within the CSA codes are mandatory, some are not. But this particular annex is a mandatory part of the code. It says the owner and operator of oil burning equipment shall ensure at least once per year that it's maintained in accordance with clauses L1.2 to L5. And again, this speaks to the tests and the requirements that are required for that piece of oil burning equipment. And just a note that maintenance also should be in accordance with the manufacturer's instructions. So there's little to no way out of it unless they can certainly prove that they're meeting that requirement. So now we get into the good stuff. Enough of the regulations. We're going to talk about what we're here to talk about, and that's fires, fossil fuel fires, right? So this is exciting. So does size really matter? Well, certainly it does, because as Kevin alluded to, the complexity, the severity, the risk of any one of these is oftentimes dependent on the type of fuel and the quantity of fuel. We talk about minimal ignition energy, and that's one of the reasons that maybe hydrogen is having a hard time, is because the characteristics of the fuel make it quite dangerous. And any fuel, as Kevin mentioned, is dangerous when it's not maintained and properly utilized. But on the left is your run-of-the-mill commercial coffee roaster. And if you happen to work on or insure coffee roasters and you haven't had a coffee roaster fire yet, just wait. But this is a good coffee roaster fire, and it's just a beautiful flame, isn't it? And in the middle, we have a type of heat treat process where we actually introduce it's called an endothermic environment into the process as the steel is being treated. And this is at the exit, the breech of the oven, the endothermic environment is burned off. So it's just a beautiful thing in the industrial side of this. And on your right is a beautiful luminescent flame of a 12 or so million BTU oil-fired boiler in an agricultural greenhouse installation. So bringing in the industrial and commercial flames into this presentation. Common causes of fault or failure, you're going to hopefully have this memorized by the end of the presentation, because whether it's commercial, industrial, agricultural, or residential, the most common causes of fault and failure are either service related, a lack of service, installation omissions, appliance or component failure, failure analysis and review of design and installation is what origin and cause can really speak to and offer you post-incident. And we can also provide a standard of care opinion on a lot of incidents that may end up going across your desk. So I won't shame myself by reciting the top of this slide to you, but I will predict the song you're going to have in your head for the rest of the day, or at least until the next slide. Packaged heating and cooling units. We affectionately call them RTUs, rooftop units, packaged rooftops. It's effectively your residential air conditioner and furnace put into one box and then set on the roof. And certain parts of North America, you'll actually find these in residential installations. It's different, interesting and different how from one location to the other across North America, we heat and cool in such different ways. But this was a lonely slide with only the rooftop on the left until just this week when one of my favorite adjusters gave me the opportunity to add to it with a second rooftop fire. So they're not that common, but they certainly happen. So anytime you come across something like this, who are you going to call? And then we go out in the backwoods and down in the holler, right? So we have some crop dryer fires from time to time, and I certainly understand and I respect and I appreciate the work that farmers do to keep everyone fed. And I understand how a lot of times their schedules and their operations are dictated by Mother Nature and the amount of time they have from season to season. But ultimately, the failure to maintain their equipment can affect their end goal. And these small holes that are on the right is part of the airspace where the combustion air, the heated air, comes through to dry whatever type of bean or corn product they're trying to dry. If you're unfamiliar with crop dryers, just picture a really big clothes dryer, and instead of putting your clothing in it, you're going to put your corn in it. So it's just this giant silo with a bunch of hot air being blasted down onto it, and it kind of shakes and allows the corn to open through these grates and fall down to the bottom once it reaches a specific humidity. Certainly, there's a lot of dry product within that corn or that bean that can settle and do different things. And when you subject that to flame and a lack of airflow, when we have a lack of airflow, we have elevated temperatures, and this results in another form of a significant loss. So the big one here, at least in my experience, is improper maintenance, oftentimes leading to crop dryer fires. We move to commercial, industrial, hot water, and steam boilers. And the boiler on the left is a pretty typical steam boiler in most large industrial applications that require this type of steam. Unfortunately, this soul is rather far gone, but on installations where there's some level of integration into the building automation system, Origin has the experience and the knowledge to be able to determine, is there a series of faults that occurred? Was there some trending in the data that would indicate a failure was imminent? The controls and the technology that are available on this type of HVAC equipment, even residential equipment, is just changing every single day. And there's no end to the information that is stored in this equipment, and that is under the right understanding, and with the right equipment, we can access that information and try and develop a timeline. Even taking away from fire losses, say the automation system, when I used to work as more of a technician in automation work, we used to call it the "Are you sure you want to be fired" button. And the premise behind that is anytime you change a parameter that could affect the operation of the appliance, you're going to get that window, right? Are you sure you want to make this change? And that was why it was the "Are you sure you want to get fired" button. But the takeaway is that all of that is logged. And again, with the right software, with the right knowledge, it can be obtained and reviewed, and again, paint that timeline of maybe why the failure occurred or under what conditions. Commercial, industrial, hot water, and steam boilers. Hot water and steam boilers are often powered by natural gas, propane, and fuel oil, of course. And common boilers, failures and faults, I'm sure many of you have it memorized. It could be related to service, a lack of maintenance, or a failure by the installing contractor. And of course, the two that aren't on this list, it could be a component failure. It could be a number of things. So if we look at this boiler, there was service done on this boiler in the days leading up to this loss. And certainly there's a number of things that otherwise could have happened. There could have been a mechanical impact. This is in kind of like a storage, like a mechanical room, but there was janitorial storage. There was people in and out of this room. So sure, it could be attributed to somebody running into it with a cart or something like that. But you have to start to look at how the maintenance was performed and what was expected of that maintenance, and can the responsibility or the fault be determined. Generators, stationary engines, as they're often called within the fuel oil code, because contrary to a lot of understanding, just because it's an engine, we think of it not being a fuel-fired appliance, but most all engines are either fueled off of natural gas, propane, or diesel. And for that reason, they kind of fall under that gaseous or liquid fuels. We're trained and experienced with diagnostic analysis. We can review maintenance and requirements that were taken within the CSA 282 code, which is the standard that governs how emergency backup power is to be maintained. We can look at the diesel storage. Anytime you have a generator capable of holding up a significant load, you better be prepared to have a considerable amount of diesel to fuel it. And there's certainly risks with having a quantity of diesel or propane for that matter. Propane oftentimes on large input appliances will require the use of a vaporizer. So vaporizers bring a risk when they're not properly installed and properly maintained. So the commercial, industrial, agricultural versus residential, as Kevin pointed out, it's a box. It's just a box until we supply it with fuel. And when we supply it with fuel, depending on how much and how much heat energy we wish to get out of it, it can become a different risk. However, the size is all relative, and the combustion process at the heart of it all is unchanged. We're still applying a fuel with an appropriate oxidizer in the presence of a spark, and we're hopefully going to control that, and we're going to effectively and efficiently burn it. Residential. We all love residential, and this is certainly a picture I'm sure some of you may have seen in different contexts before. The most common appliances within the residential spectrum are forced air furnaces. Again, going back to the geographic location of North America, it just happens to be in Ontario anyway, from which I'm speaking, forced air furnaces are the most common. And where I grew up, boilers were the most common. Everybody where I was had a boiler. I don't think I saw more than a half dozen forced air furnaces until I came to Ontario. So it's interesting. And so when I addressing people from across Canada, I'm sure that different people have different experiences. Boilers are probably obviously the second most common form of central heat in residences now. Heat pumps are certainly stepping up there, so I should have included heat pumps on this list, but I neglected to add it. Water heaters, two main types, on-demand type of water heater, and then your storage type, your traditional big tank sitting in your basement. The one maybe I left off of here that we'll bring up later is when we heat our domestic water with a boiler. So an indirect loop is typically referred to as. Ranges, dryers, barbecues, gas fireplaces, generators, pool heaters, fire pits, and last but not least, propane refrigerators. Don't leave them out. Forced air furnaces. So natural gas, propane, fuel oil, and we can have some dual fuel. And speaking to the heat pumps coming in and the rebates and the energy and how we're trying to decrease our footprint and save the world, we mix heat pump technology, but we ultimately realize, hey, it's cold in Canada and the heat pump can't keep up. So even the building code requires a alternate and backup fuel source. They don't really stipulate. So we oftentimes have natural gas fired furnaces or propane, or if you enjoy your electric bill, you can have electric backup heat as well to satisfy the requirements of the building code. Common causes of fault and failure, again, service, lack of service, modifications to ductwork. Here's where maybe we deviate a little bit or we add an additional one. And we're going to see some great slides coming up of how people, we're all aware of the housing crisis and certainly people's desire to kind of offset their mortgage. They want to add some rental income to their single family detached dwelling. Maybe they modify their ductwork in the act of adding a second residence in their basement. So we'll talk to that. And then of course, last but not least, installation failures. This was exactly what I was speaking to before. There was a file that Origin had where this was the result, and there was, a lot of discussion about how this would have occurred. And with regard to forced air furnaces, there's different designs and different iterations through time of the blower fan motor, the supply air blower, whatever you'd like to call it. Certain ones, though, they will actually modulate and adjust their speed based on the static pressure or the resistance of the duct. and they do their absolute best to maintain a specific pressure or a specific air delivery in order to satisfy the appliance, right? If we're heating up that heat exchanger, we need to move a certain amount of air across it in order to operate the appliance and to ultimately heat the residence. So in this case, they tried to make the motor work a little bit too hard until it resulted in this. Maybe it shouldn't have resulted in this. One would argue, hey, that thing should have protected itself before this occurred, but anyway. This is another great installation failure. The item on your right is commonly referred to as an evaporator coil, and in this specific design and shape, we call it an A coil because obviously it looks sort of like a letter A. And this is what is typically in most residential air conditioning systems installed just a short distance above your furnace. We'll see a picture of that on the next slide. So this particular installation, the ductwork was not really adequate for the installation. And there are certain tests and measurements that an installing technician should take after an installation. And perhaps this technician didn't. Otherwise, they would have identified what we refer to as an excessive static pressure. And with an excessive static pressure, again, going back to moving heat, we weren't moving enough heat. And the A coil in this installation failed and a fire ensued, and there was a very thick film that resulted from the combustion of the refrigerant and spread throughout the house because the furnace was blowing the air throughout. So what originally looked like a fairly simple and straightforward loss ended up being rather significant. This is a better image or illustration of the A coil installed above the heat exchanger. So just maybe on the same level or slightly below this panel is where your heat exchanger, or where the part of the furnace where the flue gases and the combustion process occurs, and then the air that's circulating through your house is passed over that heat exchanger. The installation, the manufacturer is going to require a certain clearance above that heat exchanger before that A coil, that evaporator coil, can be installed, because typically the bottom of that A coil is made out of plastic. So it needs a certain amount of air for the heat to be dissipated prior to impacting the bottom of that pan. Otherwise, well, it could not end well. Residential hot water and steam boilers. So the boiler on the left is rather kind of a newer thing, but they've been around for quite a while. It's what we would call a wall hung boiler. They are typically high input and low water volume. They have a whole bunch of fuel burning in a relatively small amount of water, and that's how it's able to transfer the heat. Very low thermal energy is in that boiler, as opposed to the boiler on the right, where we have what we call a cast iron sectional. So these are older, less efficient. You can see by the venting system on this appliance that it's definitely going to operate at a lower efficiency than the boiler on the left. Both are great designs. They each have their place. Ultimately, especially for the boiler on the left, it comes down to maintenance, because picture a high performance car, right? It's going to require more maintenance and more care than maybe your Pinto. The boiler on the right, I don't want to call a Wheel McLean or a nice old cast iron sectional of Pinto, but it's kind of accurate, because the high performance one on the left needs to be maintained. Maybe I just dated myself by saying Pinto, I don't know. So residential storage type hot water heaters, everybody knows what these look like. Typically, they're pretty bulletproof. They seldom fail. The two most common reasons for failure on these is if somebody boxes it into a corner, again, trying to make room for their fifth or sixth boarding room in their basement of their single family detached dwelling, or, there's the other exception, which we'll hit on the next slide. Just to contrast these two, they're both still commercially readily available. You can go to Home Depot and buy one yourself if you'd like. I recommend getting a trained and certified and registered contractor to install it, but that's up to you. The item on your left is what we would call the atmospheric boiler. It's older, it's less efficient. The one on your right, we have sealed combustion to a point, and we have like a fan assisted exhaust mechanism rather than relying on the buoyancy of the flue gases. So a little bit more efficient. This is what can happen if you have a flood in your basement, and other than the water heater, the only thing impacted is the rat traps. So you decide to call your insurance and try and get a new water heater because it blew up. And in the process of determining why this particular appliance blew up, I asked the insured why there were marks on the wall that looked like a water level. And they decided to tell me that there was a flood, but it wasn't a big deal, but the appliance had inherently filled with water, and they tried to fire it, and this resulted. So you can see some, you can see some deformation across the cover on the front, and you can certainly see some damage on the inducer fan. Residential on-demand instantaneous water heaters. So these kind of look a lot like wall-hung boilers, and some may confuse them with wall-hung boilers, but they're a different animal. These are strictly for domestic water. This water heater wasn't actually the cause of the loss, but rather an innocent victim, but it fit the slide, so here it is. Residential water heaters, again, we talked about this, but we'll cover it again. Natural gas, propane, fuel oil, indirect. That's when we utilize a boiler zone, our wall hung or our cast iron boiler to heat our domestic water. Could be electric if you like that thing. And clearance to combustibles, lack of maintenance, particularly for instantaneous on demand, fault or failure of the technician, the same reasons we end up with failures, and then particular attention to renovations to an existing installation. Ranges, also typically called stoves, although incorrect. I will not fault any one of you for giving me a stove fire, but for historic reference, ranges come from the days of wood burning appliances, when there was a range of rings that you would remove from the top of your wood burning stove and set your cast iron pan of the appropriate number on that opening. But that's here nor there. We just kept the name. They're typically fueled by natural gas, propane. If you're, a semi-professional chef, you might want the electric and gas iteration, where your oven is electric and only your cooktop is gas. So if you have one of those, good. There's some wood still in operation, believe it or not. Certain beliefs, even just average run-of-the-mill people like burning wood. I do. Clearance to combustibles is always an issue. Hood fan installation, failure of the appliance or the components, and of course improper setup and installation. And even looking at this picture again, this was a victim, not a cause. But if we look at the shelf that's kind of above and to the left of the teal colored pot, we can see that that shelf may very well be a little bit close to the combustible surface of this gas range. And there's certainly different requirements of electric and gaseous ranges. So one failure that's worth mentioning is when we call it a stub out or a rough in. When the gas line is installed, the manufacturer, whether it's Maytag, Whirlpool, Wolf, doesn't matter who it is, they're going to have a specific measurement and a specific location where that gas needs to extend from the wall or the floor. And the appliance will have kind of a design, a indent or a recession in the back of the appliance to accommodate that stove, and ultimately this flexible connector that extends from the solid piping into the back of the appliance, which obviously gives you the opportunity to pull the appliance out to clean if you do that sort of thing. And if that pipe isn't installed in the proper location, and if the individual installing or possibly servicing that appliance is determined enough, they could ultimately affect the integrity and the tightness of that gas piping, possibly resulting in the release of fugitive gas and possibly resulting in a fire loss. I just painting a picture. Barbacoa is the Spanish word used to describe the slow cooking of meat over an open flame. So a little bit of outside of fuels education is in this webinar too. So typically natural gas, probably propane is the most common. Those kicking it old school might prefer a solid fuel, charcoal, wood, or pellets. Certainly applying to all of them is the clearance to combustibles. And also the fuel supply being shut off when the appliance is not in use. Propane cylinder storage is another consideration, and the fuel being left on, whether it's the appliance or the fuel. a lack of maintenance. There's a grease tray which wasn't maintained. And ultimately, we know what is probably sitting directly below that grease tray is a 20 or 30 pound propane cylinder with a rubber hose that could certainly be affected by a grease fire. And if the cylinder is not shut off when it's not in use, or when it is in use, obviously we can lead to a loss. The old acronym of RTFM, which in the military, at least, I can tell you, read the field manual. And that field manual will tell you to maintain and clean your grease tray so that this doesn't happen. Clearance to combustibles. So this was a great fire to be part of. The insured told me it's been in that exact same spot for 10 years, and he refused to believe that his barbecue in that location did this amount of damage. But in that field manual that I encourage everyone to read, it'll tell you that there's an 18-inch clearance to combustibles to the rear of a barbecue. Most people, probably including myself, before I started determining why fire started, wouldn't have read that. But now my barbecue is 18 inches from my wall. And again, the guy, great guy, nice guy, fun to talk to. I love most of the insureds I have the pleasure of interacting with, but he refused to believe me. And I agreed with him that ultimately it was the fact he left the fuel on, because he shut his barbecue off. And he said he did, and I acknowledged that by inspecting the knobs and determining that the valves were in the off position. But what he didn't know was the smoldering combustion and the pyrolysis that happened because that barbecue was set up against his wooden railing. And the wooden railing was in very close proximity to his convoluted, rubber-coated barbecue hose from his endless supply of natural gas coming from his wall. So when the pyrolysis and the smoldering combustion transitioned to flaming combustion and the rubber was melted off from the hose, and the convoluted construction of this barbecue hose released fugitive natural gas, the rest was kind of history. It's an interesting comparison with corrugated to convoluted. And I think even though I'm going to exceed my time, Mark is going to yell at me, that we see the corrugated stainless steel tubing, the CSST, we see that in homes day in and day out and affected by fire. And Kevin, he'll attest, just like I will, that 99% of the time that CSST, that stainless steel corrugated tubing, will remain fuel tight when subjected to even ridiculous amounts of heat, whereas the convoluted isn't fuel tight once that rubberized coating is melted or consumed. Yeah, we're getting there, Mark. Bear with me. So clearance to combustibles, this is another one of my top 5, top 10 files that I was able to be a part of. This was a beautiful installation, a barbecue. Unfortunately, the installing contractor failed to read the manual. The field manual was omitted and the clearance to combustibles was not maintained. And this absolutely beautiful installation on the back of this very, very nice home ended like this. Pool heater fires, also very common depending on the time of the year, fueled by natural gas, propane. There are some heat pump pool heaters out there. Again, if you're into that kind of thing, the clearance to combustibles is key, maintaining and installing them. These are another appliance which has a very high input that we take for granted. Installation is important because oftentimes they're installed with an improper fuel supply, such as this one here. This appliance was starved of fuel, which ultimately resulted in failure of the heat exchanger until the point where the flame was burning into the cabinet of the pool heater. And well, here we are, right up the wall. The picture doesn't capture the amount of damage on the wall, but let's just say it was a good one. The other thing is the inferred service, right? The pool heating company gives the illusion or the impression that they're servicing the entire pool. They're starting up the pool or they're shutting down the pool for the year, but they don't employ or contract the appropriate certificate holders and registered contractors to do the work on the pool heater. They're just kind of like checkbox, it's good. Meanwhile, this could happen. We're almost there. Gaseous fireplaces. These are the unintentional fires in fireplaces, not that romantic glow that you're going for with your gas fireplace, but natural gas, propane. We could have clearance to combustibles, service, installation, lack of service. This is a good one here because this person, this is a gas log set. It sits in there and just gives a nice romantic glow. It's not efficient at all. This was an improper installation which resulted in a failure and ultimately a fire in the residence. Another clearance to combustible failure, completely didn't pay any attention to the clearances that were required for that vent. This was this is my top 5 favorite fires. It was an improper installation of the appliance, improper installation of the fuel supply to the appliance, and lightning strike struck the appliance. It caused a failure in the corrugated stainless steel tubing. But the really neat part of this is, I don't know if you can see the blue line in close proximity to that corrugated stainless steel where the fire ultimately resulted, because the ignition energy was present in the lightning strike. There was enough energy in that strike to not only compromise the CSST, but also to ignite the fugitive gas. But then the fire burning and charring that wood was enough to melt that cold water PEX line and extinguish the fire. The insured was home at the time. He heard the noise. It was a significant noise as he described it. And he went down in his basement because that was kind of where the sound was coming from. And all he saw was water pouring from his pot lights. So very, very interesting find. What else can Origin do for you? We can do failure analysis and testing and determine if a fuel actually contributed to the loss. We do testing of other things, legal review files. We can determine if a quantity of fuel was released in a significant enough volume and quantity to cause a loss, right? In the case of explosions, right? If that fuel line were left open for a given amount of time at a given pressure, how much damage, deflagration, low order, high order damage could result? We can probably do some testing and some calculations to help kind of come into an understanding of was it possible. Further testing on an appliance to determine if this appliance in fact contributed to the loss, right? Sometimes we go in and we don't know necessarily if an appliance contributed. We have lab testing that can help determine that. Water damage, water source heat pumps, air source heat pumps. This is the best picture I had of an air source heat pump. They don't fail all that often. And again, one of you was kind enough to, I consider all of you my content creators, and I'm just fortunate enough to be the storyteller. So the belief was that this air source heat pump may have caused the loss, and so I was brought in to kind of help determine that. Ultimately, what happened was there was a failure of a propane regulator down the wall from this a little ways, and the propane migrated. Kevin was kind enough to teach you about the specific gravity, the relative density of propane being heavier than air. So the propane was released and migrated down until it found the most competent ignition source, which happened to be in the heat pump. And it was a beautiful char and exit of the fire exiting from the heat pump. It was great find. We can do generator diagnosis and analysis for residential just as we can for commercial industrial. Fuel pressure, again, is a big concern with generators. Residential generators, just like large industrial commercial equipment, it'll have diagnostic capabilities. We can determine runtime, we can determine fault history. All of these things can likely be brought up because generators don't just result in, possibly they could result in fires, but oftentimes they result in losses because they fail to operate, which is obviously a loss as well. Propane is a secondary fuel source. Always close your valves. Will natural gas always result in an explosion? It's possible, but it could also just result in a good fire. Here we have an improper installation of a flexible connector through a wall, and you can see the failure resulted in a flame right up the wall. And this is speaking to that, right? Not all natural gas releases are explosions. The image on the left is just your average pilot, and you can think of your pilot just like you do the orifice of an average burner, right? And until we mix that gaseous fuel with the correct ratio of air, we don't have a flame. The picture in the middle really draws this the clearest, where we have a pipe with natural gas running at 7.5 inches of water column. A hole was drilled in it, and then obviously a flame applied, and it just burns ever so gracefully off the top of that pipe once the fuel and the air reach the proper ratio. So certainly we can have a lot of damage from the release of natural gas. And we can have natural gas or propane as a secondary fuel source, which can skew and obscure our ability to determine the actual loss of the building or the structure. And in some cases, we can actually prove where that natural gas came from. This was an incredible amount of damage, and I was ready to count this one out, and then I noticed this pipe, and it was in a significant area of char and consumption, and that pipe should have been protected with the appropriate sleeving to keep the steel pipe away from the concrete. Otherwise, you have what happened here, and slow degradation over time resulted in that pipe becoming so porous that the natural gas, even at the 7.5 inches of water column, was able to leave the pipe in just the right quantity to gracefully ignite the adjacent combustibles. Last slide, I made it. What does it mean for you? We can help you determine, was the individual certified to perform the work in accordance with, at least in Ontario, the Ontario regulations, but we also can speak to regulations and codes nationwide. We have good old Mark out in Alberta, who is well versed in Alberta regulations as well. Was the company registered to perform the work? Was the work in accordance with the codes and standards? This is nationwide. Was the loss due to a lack of maintenance? And was the loss due to a failure of a component or an appliance? And questions? And Mark, I'll hand it back over to you.
All right, thank you very much, John. Thank you, Kevin. That was fantastic. Yeah, you really came in under the wire. I do have a question here. This was near the beginning of the presentation. So I think it was, John, when you were discussing fuel storage. Question is the most common date on the date listed on the regulator and on the tank? Does it get stamped that it has been inspected for propane?
That's correct. So when a tank is manufactured, there's a code that's stamped into it, and then embedded within that code is a date. And every time the tank is requalified, it has to be requalified by an authorized company. There will be an additional stamp with the new 10-year, the date that it was done, and then it would be requalified 10 years after that. I hope that it answers the question. Mark, if needed, I keep with me there's a way to read that. Just trying to see if I can find it here. I have there's an actual document that shows you. I don't know if you guys can see that, or if anyone can see that. There's a way to understand that, which I can have Mark send that out to everybody.
Yeah, we could share that actually. That's great. Thank you. Are single wall oil tanks allowed in Ontario any longer?
There are some conditions that they would be allowed, and it would have to do with the containment of the quantity of fuel stored in the tank. They're definitely not common, and there would, I would say that the best thing we could do is the individual asking that question. If they wanted to reach out to us directly, I'd have no problem trying to help you find the information that you're looking for. There's a lot to that. It's kind of a thick onion to kind of give a blanket answer to, I guess.
Yeah, sure. Okay, we're at the time. If anyone has to leave before we, really wrap things up, by all means, you'll still get your completion certificate for the time allotted. If anyone wants to stick around while we just cover a few more questions, yeah, you're welcome to. So here's one that's technically a statement, but I'm going to read it as a question. Sounds like the issue is often upkeep. You agree or disagree with that statement?
I would agree with that, especially when it comes to fuel oil. Usually not that I'm disparaging fuel oil in any way, shape, or form, but that is the reason why that there's an annual requirement within the fuel oil code that compels the owner of the equipment for annual service. With the propane and the natural gas, I would say that it's a lot more forgiving. Most people have a furnace in their house or their water heater. It's been running completely autonomous for 20 years without issue. But with respect to anything that's usually like to John's point about something that runs, like if you have yourself a piece of equipment that's more like a race car, it's going to require more maintenance to it. But if it's something like a water heater, they're essentially bulletproof, and there's very little to go wrong. Now, the caveat to that is every manufacturer's certified installation instructions all say, please do annual maintenance on this equipment. So it's usually mentioned in every piece of equipment's installation and service manual. But yes, to answer the question, yes, lack of upkeep is usually a huge contributing cause to that.
Great, thank you. This question is for Kevin, but John, feel free to jump in. What is the oldest oil tank in operation that you have come across in your work?
So I'm also located in Ontario. On Pelee Island, there is a bulk plant, and the fuel storage tank that they use at the bulk plant is a riveted tank, and it's probably, like, I have to say it's either from the 1900s or shortly thereafter, because I had never seen a riveted tank before. So to answer your question, I would say that tank, the riveted tank on Pelee Island, was probably the oldest. Also, during the construction of the new bridge down here in Windsor, the Gordie Howe Bridge, there was a lot of land that was expropriated along the route where the highway was going to go. And during that process, there was a number. I want to say we were between 15 and 20 underground fuel oil tanks that had been in the ground and just forgotten about for over 100 years, where there used to be like farms and farmhouses. And as developments grew and the farmland became residential housing, there was just some very, very old oil tanks in the ground. Like the ones that I seen that were the oldest were underground, not above ground.
John, you top that?
I think Kevin hit it. Yeah, there's a lot of times you'll find underground buried tanks that nobody knows are there, and it's always a horror story. If I ever were to buy a house, the first question and the only question I would really care about is, was this home ever heated by fuel oil? Right? That's not that I'd be scared of it, but it's just something to be aware of.
In Windsor, in one of the major intersections in downtown Windsor, when they were in the process of repaving, they had to dig really deep. They were redoing the fire hydrants. They actually found a steel tank filled with gasoline, like completely in the ground. And it had been there for probably 100 years when the fuel was still in the tank.
Okay, we've got a question here about fuel supply lines. Are the corrugated lines now no longer allowed? Has this code changed? Has the code changed in Canada for this?
I believe, would the question be more with respect to the counter, like I know in the United States, John, do I have this correct? In the United States, they're getting away due to the lightning strikes where they're going to the counter strike. I believe that's the purpose of the question. As it stands right now, the corrugated stainless steel tubing is still allowed for use in Canada. The caveat though is they want to ensure that it's properly grounded. Like, so you have to really follow that installation manual with respect to the grounding of the corrugated stainless steel tubing.
That's correct. There's thousands and thousands of miles of that stuff installed all over North America. It originated in Japan, right? It's not a new product. The key to it is it was never meant to be like a do-it-yourself installation project. And I think that's a lot of where the failures came from in the United States. I don't think there's that many documented failures in Canada. I consider myself fortunate to be privy to one, right? So, but at the end of the day, as Kevin mentioned, it's all about proper installation. So if that's done.
I can remember when corrugated stainless steel tubing entered the market, and to what John said earlier, you used to be able, you still can purchase a power vented or an atmospheric water heater at Home Depot and put it in your house. And I can remember when Lowe's first came to Canada, that they were selling corrugated stainless steel tubing for a brief period of time, and then overnight one time it disappeared. And I don't know, John, if the reason was due to the installation errors of it, but one day it was there and the next day it was gone. Like for you could still purchase it at a HVAC wholesaler, but it was being sold like you can buy gas pipe, copper tubing, but they did remove the corrugated stainless steel tubing for I don't know what reason.
Okay, yeah, thank you both. Okay, let's move on here. When it comes to auto/annual oil filling, isn't it best practice to ask the customer if their tank has been removed before coming?
From a fuel distributor perspective, there's again, I can't speak to all areas of the country, but specifically in Ontario, there's requirements. Actually, it's within the code, I believe. So it would address the entire country to the requirements required when a what we call a change of energy, right? They're getting rid of their fuel oil system and they're going to heat pump, or natural gas is down their road, or they decided propane, right? The fuel oil distributor is part of that notification process, so it should happen. There's certainly administrative mistakes or mistakes on the fault of the installer. And again, that's where if there were a loss that was due to the basement being filled with oil because the tank was removed, that would certainly require a lot of questions being asked as to who did it, how it was done, and what actions were taken.
Okay, would either of you like to comment on gas meter protection? So who's often responsible for installation?
So there's a code. So typically with the gas meters themselves, which are owned by the utility, they have a separate code, which was with respect to like more of the underground application of that. The protection of the meter is normally the responsibility of the utility, and it's outlined in that code. And essentially, I believe it has to be there's like a 4-inch piece of pipe that has to be sunk 4 feet in the ground and then filled with concrete. I believe that's the it would. But to answer the question, the protection of the meter, if it's the property of the utility, would be with the utility.
There's also the statement to the effect of like good engineering practices and things like that too. But
I get like my time at the TSSA over 10 years, we would identify, or we would categorize the impact of a meter as a vapor release. And typically when we go there, it was the vehicle or the meter was impacted by a car. And we would exercise at the time TSA or judgment. Like if it was in the middle of a field, the car's not supposed to be in the middle of the field, but if it was beside the house, it would be the responsibility of the utility to protect the meter set.
Okay, I've got so this is in relation to heat pumps. And with some jurisdictions applying considerable effort to eliminate natural gas for home heating, will we see a revised building code?
So the 2024 building code is now in effect. I would have to double check, and we can follow up on this question, Mark, but I think that there's no official drive from the Ontario or the National Building Code to push this. I think this is it's a green initiative for sure. The building code, I don't think speaks to it. It's not like I know there's certain municipalities in the United States and in New York where you can't build a new home with natural gas. We haven't gotten to that point, at least as far as I'm aware, anywhere in Canada. As far as the building code speaking to heat pumps, I think the only thing is that item that I mentioned where there has to be an alternative backup form of energy, which could be in the form of electric resistive heat. It could be in the form of natural gas forced air furnace. It could be in the form of a boiler, any type of those things. I built a new house not long ago. I have a heat pump, but I also have a natural gas fired boiler. So I satisfied that with having an alternative form.
All right, excellent. So we'll do 2 more questions here, and then we'll have to cut it off. So this one, with the new Cadillac Roth oil tanks, you see as many leaks?
Personally, I've never seen a leak in a Roth. The only failure of a Roth I've seen was due to improper installation.
Okay. And last one here. Sorry, two more. This was because one was the same person, two questions. So also, when we get the oil furnace checked yearly, is the oil tank checked as well?
Absolutely. That's part of those requirements within the code and the specific tests and observations. So the tank, the piping, the appliance are all under that.
All right, fantastic. Last one, here we go. As being an insurance home inspector, we're told that the outdoor oil tanks are only good for 10 years and inside 15 years before replacement is required. Is there any legislation saying this?
So not that I'm aware of. Again, speaking to that, I believe in the question, correct me if I'm wrong, Mark, it was the insurance requires it. And that's to their prerogative. They can, it's a risk base, right? So if they say, hey, we've seen 100 tanks fail at year 11 or year 12 or year 13, we're going to require it to be replaced at 10. And certainly from a risk perspective, that would be something they could do. But in my experience, in my knowledge of even Canada-wide, there's no regulatory or legal requirement. And if I'm incorrect, I would love somebody to correct me. But you know, a tank in the proper environment, under the proper conditions, like to Kevin's point, it'll last forever if it's cared for, maintained in good humidity. It's not in a, you know, wet, damp, rat-infested basement. Like, we're good.
Okay, all right, great. I think that that just about covers it. So Kevin, John, thank you so much for giving the presentation. Very interesting. And everybody who attended, thank you. Thank you for sticking around while we kind of do these questions. And last point, when you leave, you're going to get a short survey. One of the questions on that survey is, do you want to automatically be registered for our next webinar? And that's coming up at the end of the month. So just click yes, and you won't have anything to worry about. We'll get you all set up. Okay, guys, thank you very much. And everyone else have a great day.
Thank you, everyone. It was my pleasure to speak to all of you.